Alright guys, so we're going to talk about how to perform sequence of transformations when you have similar figures in the coordinate plane. So we did congruent figures before, but here we're going to do similar figures. Alright, so our key vocabulary here is similar transformations, similar figures, corresponding sides, scale factor, and ratio. So here, with similar transformations, what all that means is a sequence of transformations that will map dilated or similar figures onto each other. So, what's the definition of similar figures? Same shape, different sizes. Corresponding sides means matching sides, and I'll show you what that means. A scale factor is represented by K, and if K is greater than 1, we get an enlargement. And the scale factor is the multiple in which the picture is blown up or reduced by. If K is less than 1, then we get a reduction. Okay. A ratio is, we'll say the comparison of two quantities. And in our case, in this situation, we're going to say written as a fraction. So an example of a ratio can be if I have 3 to 1, then I write it as a fraction, 3 over 1. Okay, so let's go ahead and talk about our examples. It says in exercises 1 through 3, graph the polynomial with the given vertices and its image after the similarity transformation. So here, I'm going to go ahead and graph the pre-image. So that tells me to go to 3 and 6, and then say to name it A. And then go to B, 2 and 5. That's my B. And then 4 and 3. That's my C. And then 5D would be 5 and 5. So 5 and 5. That would be my D. So if I connect the dots, I get a figure that looks like this. Let me double check. So see how I did that backwards? A, 6 and 3. That's not what it said. It said 3 and 6. And guys, it's okay to make mistakes. This is why I model my thinking. If you're the type person that makes mistakes too, that's why we do math and pencil. Oh man, I know I gotta go graph all over. So this should have been 3 and 6. That's my A right there. What was B? B was in the right place. 2 and 5. It's okay to make mistakes. Just go back in and fix them up, babies. Don't beat yourself up or stress about making errors. Everybody in the whole entire world makes errors. Just learn from them and keep going, babies. Did I get it right this time? Yeah, 3, 6. So just remember X goes first. And some of you make those errors too, and it's okay. So I have a translation, then a dilation. So I need to do these two and then put them on the coordinate plane. Okay, so to get A prime, it tells me to subtract 5 from each x value. So A prime subtract 5. So here 3 minus 5 would be negative 2. And then I need to subtract 3 from the y. So that would be positive 3. To get B prime, I subtract 5 from this. So I get negative 3. And then 5 minus 3 is going to be positive 2. And then to get C prime, then I do 4 minus 5 is 1. I mean negative 1. And then 3 minus 3 is 0. And then when you do D prime, 5 minus 5 is 0. 5 minus 3 is 2. Now you can go and graph that. I'm not going to graph the in-between one. I'm going to go to the last bit of the sequence, which it tells you this is a dilation where the scale factor is 3 in this case because both values of x and y is being multiplied by 3. So my scale factor there is 3. So it's telling me to take each one of these coordinates and multiply it by 3. So my final result, which is going to be A double prime, is negative 2 times 3, which is negative 6. 3 times 3, which is 9. My B double prime would be negative 3 times 3 is negative 9. And then 3 times 2, which is 6. My C double prime would be negative 1 times 3, which is negative 3. 0 times 3 is 0. And then my D double prime is 3 times 0 is 0. And then 3 times 2 is 6. So here I'm going to go graph my final result. Now, if you want to graph the prime in between that, that's fine. But I'm just going to stick with the double prime because that's where I end up at the end. And so I get negative 6, positive 9. That will be my A double prime. And then negative 9 and positive 6. That will be my B double prime. And negative 3 and 0. That will be my C double prime. And then 0 and 6, which would be right here. And that would be my D double prime. So, in this case, here's what happened to that picture. And I got a point wrong somewhere. So, I got B in the wrong spot. So, these should be the same shape, but different sizes. So, here, this should be 2 and 5. So, that should have been right there. And that's how I knew something didn't quite look right. So, here, for B, 2, 2 and 5. 2 and 5 is right here for B, okay? And then, let me make sure I got D right. 4, oh, okay, so I got D in the wrong spot too. This should be 5 and 5, so right here. And there we go. And then on C, C should be negative 1 and 0. And D is 0 and negative 2, which should be right here. So I'm demonstrating right now. If you guys, oh wait, I'm tripping. If you guys make mistakes, it's okay. And here we go. So something is still wrong with my pictures because these should be the same shape but different sizes because I did a translation and then I did a an enlargement. So it looks like A and B are okay. It looks like I messed up at C and D. So I'm going back and I'm checking my C to make sure I have it in the right spot, 4 and 3, and my D and make sure I have it in the right spot. So that's 5, 1, 2, 3, 4, and 5. So my A, B, C, my original or my pre-image is okay. So let me go check my math. So here, 3 minus 5 is negative 2. 6 minus 3 is 3. So I got that right. And then 2 minus 5 is negative 3. And then 5 minus 3 is 2. So that's okay. And then 4 minus 5 is negative 1. And 3 minus 3 is 0. And then here 5 minus 5 is 0. And then 5 minus 3 is 2. So I'm good. My scale factor is k. It says to take both the x and the y value and multiply it by 3. So I take the previous results, negative 2 times 3 is negative 6. 3 times 3 is 9. Negative 3 times 3 is negative 9. And then 3 times 2 is positive 6. Negative 1 times 3 is negative 3. 0 times 3 is 0. 3 times 0 is 0. 3 times 2 is 6. Alright, so I know where my mistake is at. I made a mistake right here. So I need to take this away. And I need to go fix my graph and do 0, 6. So 1, 2, 3, 4, 5, 6. Now I'm on track. So a lot of you make mistakes like this as well. But here's how you check your mistakes. You catch your mistakes by knowing your definitions and knowing how what's supposed to happen to the pictures. So I knew these were supposed to be the same shape but different sizes, because if I have a dilation, then I'm not going to change the size of the shape. I'm just going to make it big or small. And if I do a translation, that means I took the original picture and just slid it to the left 5 and down 3. And then I needed to have blown that picture up by multiplying it by 3, the coordinates by 3. So you guys make mistakes like this as well. And that's why I don't mind showing my thinking to help you get comfortable with going back and knowing how to, 1, it's okay to make mistakes. 2, to go back and check yourself and use your vocabulary and things that you know to help correct your answers. So I just showed you how you can go back through that and fix your thinking. All right, so that's this picture. And it said, what's the rest? Graph the polygon to give the vertices in this image after the similarity transformation. All right, so here are the vertices for what we needed down here for the original, for the image, the final image. Okay, so let's try this next one together. It says in exercises 4 through 6, describe the similarity transformation that maps the pre-image to the image. All right, so if we look at this, and I am going to take a picture of this, and on your oh boy, hold on, let's try that again. So I'm going to take a picture of this graph. And you know what? I ain't going to need to do it this way. I'm going to use snipping, guys. That's just quicker for me. So I'm going to take a picture of this. This is the pre-image. And I know this is the pre-image because it does not have any primes on it. Come to this page, Control-V. All right, so I've taken a picture of this, and I'm going to put it on top of this one, and I'm going to make it transparent. And what you can do, you could take a sheet of paper and do what I'm doing right now. You could take a sheet of paper and trace the computer screen so you can move the figure around like what I'm getting ready to do. All right, so it says, so what I noticed is that if I take this picture here, and it looks like I slide it to the right, and I move it over, I get my first transformation. I get it there. So I would say that the first transformation would be to do some kind of translation. I need to do some kind of sliding. So it looks like I went to the right some. So it looks like in order to get n over to n prime, I'm going 1, 2, 3, 4. Well, it looks like 4 to the right to get it lined up on the same line, which I lined it up right here. So I went to the right 4, and then something happens to the y. So I'm going to go here and go 1, 2, 3, 4. So it looks like I also have to go down 4 to get the n prime lined up. Well, it looks like we have a, well, okay, yeah, I go down 4 to get the n prime lined up. But now I'm kind of big, so I need to do some dilation. So now I need to take these coordinates and do a dilation to it because it's a shrink. I need to shrink it down. So I know my k is going to have to be less than 1 in this situation. So how far do I need to shrink it down? So I know it's going to be some kind of fraction to get this picture to shrink down to the pre-image. So I'm going to look here. I'm going to count my sides. So what I'm going to do is I'm going to say, I know this side matches this side. And I know that LN matches LN prime. And I also know that MN matches ML matches ML prime. So I'm going to find my scale factor to find what K is supposed to equal. I know that I'm going from a big picture to a small picture. So I'm going to say small over big, since that has to be a reduction. And I'm going to count my sides. I'm going to count and I'm going to do the yellow side since it's not that many of them. This is 1. So I'm going to say 1. And then this up here is 2 boxes, 1, 2. So I get K equals 1/2. Now I want to check myself out and make sure I'm right, because our definition for similar figures tells me that the ratio of MN over MN prime should equal the ratio of LN over LN prime. That's what it should equal. So if MN, now I'm going to flip this since this is going to be a reduction. So MN prime over MN, and then LN prime over LN. Those should be equal. So we already got this is 1 and that's 2. And does that equal, this side is 1, 2, 3. LN has a length of 3. And then LN prime, 1, 2, 3, 4, 5, 6, has a length of 6. And do that equal? Yes. So my scale factor is 1/2. So here I'm going to tell the person, multiply both the x and the y values of the original picture by 1/2. And then we will be able to shrink this down. Oops, wrong one. I need this one. Alright, so if I multiplied those coordinates by 1/2, it would shrink down and fit on top. And then we finish. So you have problems to practice where you graph the transformations on the coordinate plane, and these are called similarity transformation, because the ending figure is ended up either in a reduction or an enlargement. And here you have to do the sequence of transformations. So go ahead and work through these problems, and I'll see you in class. Bye.